Hi, welcome you all on Physics Addhyan. So, in the previous lecture of mechanics, we have studied about circular motion, and today we are going to recap the projectile motion because this topic you all have might studied in your 12th class. So, it will be a short introduction to projectile motion, and then we will go directly to problems that are mixed on projectile motion and circular motion. So, let's study this. What is a projectile motion? So, few things which I wish to comment on this. First is it is a two-dimensional motion or a planar motion. And the second thing it is under the constant force. So this motion is under constant force. Motion is under constant force, and that constant force here it is gravity. That is gravitational force. Gravitational force. So from the general theory of this types of motion, we know if there is a some force, let's say F, and that is constant. So for this type of constant force, there are two types of paths that are possible. The first is that is the straight line path, and the second path is that is a parabolic path, that is parabola path. So when force is your constant, then there are two types of paths that are possible. That first is the straight line path, and the another is your parabola path. So this paths depends on the velocity. So if your initial velocity is 0, then the path will be your straight line under this consideration that the force is constant. So if initial velocity is 0, then the path is your straight line. So let's do one more thing which I have told in the very beginning of this lecture. So if force is constant, then that accelerations is constant. So if acceleration ax, ay and az are constants, then you can directly use the equations of motion. Directly, because the equations are motion valid and only for constant acceleration. So this was the few things which I just recapped from the projectile motion. So, and one more thing, that is about when u is not equal to 0, when that initial velocity is not equal to 0. And first thing, that u velocity, that initial velocity is less than the v escape velocity. That is a consideration under this projectile motion, that your initial velocity is not as greater than the escape velocity from the earth or whatever, wherever you are, because when you have a very high speed, then the path is not parabolic, instead it is an elliptical path. And the second thing, when the velocity is very high, your force constant is not applied, because when you go to very high height, your force changes because of g changes, your acceleration due to gravity changes at very high height. So when force is not constant, or your velocity is not greater than, but velocity is comparable to v escape velocity, then the path that are possible, which is ellipse. So the possible paths can be elliptical. So this was the type of motion. So now let's do a quick recap of the projectile motion. It's equation of path and some problems we will do in projectile motion. So let's start our discussion here. So first is projectile on the horizontal surface we will discuss, that is projectile motion on horizontal surface. So consider there is a horizontal surface. Let's call this as, no, I will call later this as x, and this is some vertical axis. Okay, so let's call this as an origin. This is an x-axis, this was an y-axis, and initially you have some particle of mass m at the origin, and you have some velocity. Initial velocity you give some, that is u, at some angle theta. Then what will happen, this particle will go in some this type of path, and it will return to some distance, some at some point at x-axis. Okay, This was the type of motion that is supposed to be, and this type of motion is possible under the constant force. Let's gravity G is acting downward direction, and we are taking the normal coordinates that this is the plus direction, and this is the plus y direction. Okay, so now let us write the equations of this motion. So let's first start with acceleration. So, and one thing I wish to tell you all, that these are two-dimensional motion. This is a two-dimensional motion under a constant force. So you can split this two dimension into two different directions. That is x directions. You can solve x directions equation of motion separately with y directional, because x and y are independent of each other in the coordinate system. So first thing, if I wish to write the x acceleration and the y acceleration, let me change the color. So your x acceleration is 0 because there is no component of gravity on the x direction, and your y component is your minus g. I am writing minus because I am choosing the downward direction to be negative. So my y component is 0. So if I write the x component of your velocity, so my axis is like this, x, y, and this is your velocity u with some angle theta. So your ux will be this and uy will be this, the initial component of the velocity. So your ux will be u cosine theta, and your uy will be u of sine theta, and both the signs are positive because this will be in this direction, this will be in this direction. So this is our ux and uy. Now let us consider at any given instant of time t, let the position of this particle will be at x comma y, and I am interested in these coordinates x, y and time t. So write the equation of motion. So now I am going to write the equation of motion. So your x equation will be x is equal to uxt plus half ax into t square. This is the x directional second equation of motion, that is s is equal to ut plus half at square. Now, and the y equation will be your simply y is equal to uyt plus half ay into t square. So this equation will become, your x will remain x at time t, your ux is equal to u cosine theta and time is t, and your x-axis acceleration is 0, so it will be plus 0, so it will remain x is equal to u cos theta into time t, and your y equation will similarly will become y is equal to u of sine theta into t minus, because of minus g, ay is minus g, minus half g t square. So this is your x y equation of motion, and that is your x equation of motion. Now I wish to define some of the parameters that are usually defined in this type of motion. So first is your time of flight. Time of flight. So time of flight is defined as the time taken by this, let's say this is O and this is A. So this is the time taken by the particle O to travel from initial position to its the final position, from here to here. So from O to A via this curved path. So this is the time taken. So let me write the initial velocity and time. So at time t is equal to 0, its coordinate was x is equal to 0 and y is equal to 0. So this is at position O. So at position A, its x component will be, let's say, x, and y component will be your 0 when time is equal to capital T, and this capital T I am defining to be the time of flight. So A coordinate will be x comma 0 and O coordinate is 0 comma 0. So I am finding the time that is traveled from 0 O to A. So let's substitute this equation, because y is equal to 0 in your equation number 2. This is equation number 1. So your y is equal to 0, u sine theta, this is in second equation, remember this, minus into capital T, that is the time of flight, minus half g t square. So this implies that your half gt is equal to u of sine theta. This implies that your t, the time of flight, is equal to 2u sine theta upon g. So this is the total time of flight that this type of motion, the particle of mass m, will take from 0 to a. And the second thing, this time of flight is independent of the mass. That this does not depend whether you throw a 2 kilogram particle or 20-gram particle, but you should throw with the same height, sorry, same initial velocity under the same conditions. So this is your called the time of flight. So remember this expression, we will use this in later our calculations. So this is the time of flight. Let me introduce a next second definition or second type of formula, that is, let's say, what is the range of the particle. So range is defined in this problem. Let me go back to the picture. So okay, so in this problem, range is defined from the position radial distance from 0 to a. So it is the distance in x direction that is traveled from 0 to a. So from O to A, the distance that is traveled in x direction is the range. So okay, so here the position is your 0 comma 0, here the position is your x comma 0. If we are taking the time to be the total time flight, that is the time of flight, then their x is equal to r, because when you have fixed that t is equal to capital T, you are reaching from this path to this path, and now we are going to calculate the r, that is the range of this projectile motion. So at time t is equal to 0, u was at position 0 comma 0. At time t is equal to t, u will be at position x, that is equal to r comma 0. So use the the first equation where it was x is equal to u cos theta into time t. Now this time t is equal to capital T and your x is equal to r. So r is equal to u cos theta and your t is equal to 2u sin theta upon g. So your range will be u square, and you can combine this sin theta 2 sin theta cos theta as sine 2 theta. So u square sine 2 theta upon g. So this is the range of the projectile of this on the horizontal surface. So you should also remember this formula, okay, that u is equal to r is equal to u square sine 2 theta. So what will be the maximum range? Because if you throw an projectile from at this angle theta, it will go something like this. If you throw with some different angle this theta, it will go something like this. If you increase the angle, it will go like this. So this distance x, or whatever you call as r, or whatever distance you call it as r1, xr and r1, so what will be the maximum? That depends upon the angle theta. So okay, so maximum range depends upon the angle theta. So if we want to calculate the maximum range, then we have to put this into, because theta is a variable, then we will put that for maximum range sine 2 theta should be maximum, but sine theta maximum value is your in positive sense it is +1. So your sine 2 theta is +1. So sine theta is your sine 90 degree, or your theta is equal to 45 degree. So for theta is equal to 45 degree, your range is equal to maximum. So this is for range maximum, and this is equal to u square by g. So you should also remember these, because we will use them frequently, the range, maximum range, time of flight, and this type of concepts. Now let us define the third thing, that in this type of motion, what is this height given by at particular u, at particular theta, what will be this maximum height? So why I am calling this as maximum height, you will see here that if you fix a theta, let me fix a theta like this. So the projectile, let's say this is like, its motion is like this. Let me fix another theta. its projectile will be like this. If the theta is very small, then the projectile will be something like this. So for each value of u, let's say the u is same, or it may be different, let's fix it as same. So for if u is same for different angles, theta 1, theta 2, theta 3, you have different maximum heights. Okay, so for particular theta and particular u, what is x, what is the value of that maximum height, what that we are going to see here. So now the third parameter that we are going to deal, that is the concept of maximum height in the projectile motion. Maximum height. So here we are going to use the concept of maxima and minima, that is basically the more general concept from differential calculus. So here the situation is that I have an x-axis and y-axis, and I want to find the maximum height along the y-axis. So our y equation of motion is y is equal to it was something like u sine theta into t minus half gt square. So for a particular value of u and theta, the maximum height u is depends upon the time t, because at different times intervals the height is different. So there will be a particular time t in which that y is maximum. So I want to find that time t, at what time t it is maximum. So from the knowledge of our calculus, we should differentiate with respect to time. The first derivative should put equal to 0. That will give you the time at which y is equal to maximum or minimum. Then we should check the second derivative, whether that time depends to maxima or minima. Okay. So let's do the first derivative of this equation. So your dy by dt will becomes u sine theta minus half g into 2t. So t will cancel. This implies that your t will be u sine theta upon g. So our time is u sine theta upon g. So at this particular time, your y will be either maximum or minimum. So this is your homework. You find out the second derivative and it comes out to be positive. It means no, it turns out to be negative. So let's do. Okay. So the second derivative dy by dt square is equal to 0 minus g. 0 minus g. It has negative value. So this confirms that the time is your. This will give you the maximum. And if you stare at this formula that t is equal to u sine theta upon g, this is nothing but that is t by 2. That t is your time of flight. That was 2u sine theta upon g. So u sine theta upon g. And it is obvious in this problem, because if you see this argument by symmetry, then the time which has reached to maximum, let's say this is t. And when it's come down, that should be similar, because initial and final positions in y directions are same. So you can directly take t by 2, but this is the most general approach, because sometimes you don't have your y symmetry, this type of symmetrical problem. Then you have to find the maximum height using this differential calculus term. Okay, so till now we have calculated that for t is equal to u sine theta upon g, whatever my y will be, that will be maximum. And this y maximum I will be writing as h, that is the maximum height. So my y equation is, let's call this time as t star. My let me do it another way. Let me call this time as t star. So my y equation was y was my u sine theta into t minus half gt square. So substitute this equation as t is equal to t star and y will be maximum, that will be given you h. So your h is equal to u sine theta multiplied by t is equal to your u sine theta upon g minus half g into u sine theta upon g whole square. When you calculate it, you will get u square sine square theta upon this will be 2g. Yeah? U square sine square theta upon 2g. So that is the expression for your maximum height at a given u and theta. Maximum height. So till now we have calculated the time of flight, and we have seen that this does not depend upon mass. Even none of the quantities depend on mass. Time of flight. And the second thing was your range. And the third thing, we have defined the maximum height. So these three parameters we have calculated, and I again say you that you should remember these formulas, because at the time when you will applying it, you are not going to derive all these known results. Now we are interested in path of the projectile, that what is the equation. So if I took this type of motion, so this is your let's call it as x, this is 0, this is y. So at any given instant of time t, this is your coordinate x and y. I want to find the relation between this x and this y. If you get a relation between x and y, that will be your projectile path. So that is true for any discussion, any of your mathematics calculation, anywhere. If you have to find the if you have to find the path of that equation or path of that curve, you have to find just the relation between those parameters. So here the parameter is x and y, so you need to find the relation between x and y. So this is equation of path, equation of projectile path. So our equations, the basic equations was x is equal to u cos theta into time t, y is equal to u sin theta into t minus half gt square. So see, there is a time parameter here and there is a time parameter here. So we just need to eliminate the time to get the equation relation between x and y, because that is a common thing. So your y is equal to u sin theta, and you substitute the time t is equal to x by u cos theta here. So you will get u cos theta minus half g t is x by u cos theta whole square. So you will end up getting the equation y is equal to your you cancel x tan theta minus your g x square by 2u square cos square theta. So that is your equation of motion. So at any given instant of time, if you know x, you can determine the corresponding y. So this is called the equation of motion of this projectile motion. And you can see with some factors, you can write this equation as something as y is equal to x minus a whole square. With some other parameters, you have to you have to just make it a perfect square, because this will give you x square plus 2ax plus a square. So x is here, x square is here, this x is here, so you have to add and subtract some things and you will get this types of equation. So this equation is nothing but your parabolic equation. So this confirms that the equation of that the path of the motion is parabola. Okay, so this was the discussion on the projectile motion. Now I wish to have one more problem that you have not I think you have encountered, but I'm not sure about that, so I must discuss it here. That you have some parameters, okay, you have some initial velocity u, some angle theta. Okay, so let's again go to this discussion that I have an x y axis. Let me draw it first. X y, okay, 3 will be enough. So if I choose different u theta with same u, so this is your u with some angle theta 1, This is your another u with some angle theta 2. This is your some another will angle theta 3. So this path will something like this. So do you see the area under the curve? That is also different. So in first, let us, the area is A1, this area is A2, this area is A3. So area depends upon theta. So now my question is, what is the angle? What is the projectile motion? Okay, sorry, let me rephrase this question again. So what is the angle at which the area under the curve is maximum? So this is the type of problem that we are going to deal with. The next problem is this, that what is the angle at which the area under the curve is maximum. So let's do this problem. So I'm not going to completely do this problem. I will do some steps and I will write the final result so that you can verify with this, and this will be an exercise for all of you learners. So let's see that with given angle of theta and given this is some angle, okay, this is at some velocity u with some angle theta. So this area we are going to find out under the yx curve. So area, if you write, that is simply double integral of dx into y. So your first integration dx will go from 0 to some range r, and your dy integration will goes from 0 to some y, because y will vary from 0 to some y, and x, this is a y strip. Okay, so this is your y strip. Let me make a strip with different color. So this is your y strip. Consider a strip, so that will go from 0 to y, and you displace this strip from x is equal to 0 to r. So that will be your total area. Okay, so this is 0 to r. So this you will get 0 to range into dx, and this integration will give you simply y, but I know y in terms of x. We just derived it. That is x tan theta minus g x square by 2 u square cos theta. So if you, I am not doing all the calculations, so if you do this, then your area under the curve will be 2 by 3 u raised to power 4 by g square sine cube theta cos theta. So how would you get that? You just integrate with respect to this. You will have a limit on this range r, and put this r is equal to u square sine 2 theta upon g. You will get area to be this. Or I'm sure you will get this if you do the calculations, because I'm not doing it all here. So this is a general area under the curve that will depend upon this angle theta. Then again we are going to use the concept of maxima and minima. So let me close up. Okay, yeah, that's good. So for area to be maximum, you have a condition that your sine cube theta cos theta term, because that is only the variable that depends upon theta, so that should be maximum. So let's do the differentiation with respect to theta. This is sine cube theta cos theta, so this we have to put to 0, and if you differentiate it, you will get sine square theta minus sine square theta, and the one you will get 3 cos square theta, something like that, and it is equal to 0. So the first thing you will conclude that your sine square, I have skipped some steps in intermediate steps of this differentiation. I can say that you can do this type of calculation at your own. So your sine square theta will be equal to 0, or your sine square theta, the second term is sine square theta is equal to your 3 cos square theta. So this will give you tan theta is root 3, so theta is equal to pi by 3, that is nothing but 60 degrees. So this is your one answer. And second answer is your theta is equal to 0. So this is a trivial answer. When theta is equal to 0, your area will be maximum for that u, for that velocity u, because it will give some x directional motion, and that x will be your total, x into y will be your total area. So that is the trivial solution that we are going to discard here. So your theta will be 60 degree. So at 60 degree angle, if you projectile it will 60 degree, your area will be maximum. At 45 degree, your projectile range will be maximum. At 60 degree, your area will be maximum. You can put the theta is equal to 60 degree and you can find what the maximum area is. So this was about the very simple case that you all have encountered in your class 12th. Now we are going to do some analysis on projectile on an inclined plane. So what happens if you have a plane that we just did like this horizontal. Now if it is some inclined at some angle, let's say it is inclined at some angle alpha, and now what happens to this type of motion? So let's consider that there is a projectile at some mass m and it is projected at some angle theta with this horizontal at some velocity u, and this is projectile at some point here. Okay, now I am calling this axis to be x-axis and corresponding this axis to be y-axis. Now my only the difference is my x and y-axis are changed. Even in this problem, your gravity will be downward in this direction. Your gravity will be downward in this direction. Now, what are the changes that you expect? First thing, that your acceleration ax is not 0 here, because you have some, if let me write down the components. So if this is your, let's say g at this point of motion, so you can similarly draw this type of components in x and y direction. So this is in y direction and this component will be similar. Okay, so let me use a different color. So there will be a component of this in this direction, and this will be component in your y direction, and this is your net g downward. So this is g, and if you carefully analysis, this angle is same as alpha. So this will be mg cosine alpha, this will be mg sine alpha, that is cos and sine. So your x acceleration that was initially 0, now it is minus g of sine alpha, minus because I am taking this to be positive direction of y, this to be positive direction of x and y corresponding. So your ay is also your negative, so this will be equal to minus g of cos alpha. So that is the biggest change we have seen here. And I think your ux will be remain same as u cos theta, and your uy will remain as u sin theta. So your x-axis acceleration and y-axis acceleration are same. Now I am going to do the similar thing, define some parameters. First is your time of flight. Now what happens, let's see. So your time of flight, the first equation is ux into t plus half ax into t square, and your y is equal to uy into t plus half ay into t square. Now this ax is not equal to 0, so it is not too easy to, not too difficult, but not also too easy to solve this equation. So your x is equal to u cos theta into time t minus half g sin alpha into t square, and similarly your y equation will be u sin theta into t minus half g cos alpha into t square. So this is the equation of motion. So again, now time of flight is defined as the time taken from this particle from point A that has to travel to point B. Again at this point y is equal to 0. So let's substitute this y is equal to 0. So you will get u sine theta into capital time t, that is your time of flight, is equal to half g cos alpha into t square. So you will get t is equal to your 2u sine theta upon g cos alpha. So this is your time of flight in this type of motion. So let's see whether we are getting the old result or not. So if you put alpha is equal to 0, that is the horizontal motion, so this t will be 2u sine theta upon, because cos alpha will become 1, so your time of flight exactly matches with the previous solution, that is 2u sine theta upon g. Now I am assigning you as a homework. So now similarly you can find out these other two parameters in the same way which I have discussed earlier. So the second parameter is your range, and the third parameter is your maximum height. So in this types of motion, you know ax, ay, ux, vy, and I have derived u for time of flight. So in the similar way which I have did in the last case, you can find out the range and maximum height. I am not going to do it here. That's your homework, that's your task to do it. Okay, so that is enough for the projectile motion. So in the next lecture, we will be studying some problems on projectile motion and some problems that are crossed with circular motion. Thank you.